Hello everyone and welcome to the Thermofluids team. I hope you all are doing great despite the many situations around us. My name is Tanmay Agrawal and I would be taking this course on fundamental fluid mechanics. The whole aim of this course is to provide you a basic understanding of fluid mechanics and how we can use the understanding to solve the real life applications of some problems that involve this fluid flow. So next the question comes, where does this fluid flow actually happen? So to answer that, you can look in many different ways. You can look around us. For example, you can look at the flows of water in rivers or canals. You can look at the flow of air in the atmosphere. You can look at the flow of blood inside the human body. You can look at the flow of lubricants inside the machineries. There are a lot of applications that involves the fluid mechanics. So that is why understanding how the fluid flows and how it affects the many different things around it, it becomes very important. So this subject is more on the fundamental level. So I'm looking at students who are just starting their study into fluid mechanics, but I know that some of you are really, big shots. So I'm also taking those guys into account. So we would be, at some point, we would be diverging more about the advanced concepts. It could involve the solution of the fluid flow problems on computers, such as using certain software packages. We can also obtain the solution of flow problems and could predict the quantities that are of engineering importance. But in the lecture today, I want to give you an outline of what you can expect from this particular course. And in the next lecture onwards, we would start talking them one by one. So this particular course is roughly divided into 6 parts. So in the first part, we would talk about the terminology that is associated with the fluid mechanics and a general fluid flow phenomena. So we would talk about the various kind of fluid flow that one can expect in or from an engineering viewpoint, and the various kind of quantities and the terminologies that are associated with the subject. So this is like a formal introduction to the subject, because if you don't really know the A, B, C, and D, you're not supposed to know the apple, ball, cat, and dog, right? So this is the ABCs of the fluid mechanics. So the second unit of this course would deal with what is called as pressure, and will also deal with the subject of fluid statics. So we have been saying that we are going to determine the fluid when it's flowing and all that stuff, but we also need to understand what happens when the fluid is simply sitting in one place. For example, you know that the dams are built where the water is collected over time and the water just sits there. But we need to know how much water should be sitting there without breaking the dam. So that force becomes the quantity of engineering importance, because if we don't estimate that properly, catastrophe might happen. So fluid statics, it deals with the study of fluids at rest. So we will be talking about fluid statics. So before the fluid moves, we want to understand what happens when the flow doesn't really happen, when the fluid is simply sitting. The third unit of this course would talk about a very famous Bernoulli equation. And in other words, we would talk about the acceleration. So now, the fluid which was sitting earlier, we now start to move it. So we are going to study what happens when the fluid moves, but we're not really interested in understanding what happens on other objects, like what does it apply any force or any drag. We are going to study the parameters such as velocity, acceleration, and the position of the fluid, which are also considered as what is called as the kinematic quantities. So we're going to study the fluid kinematics. So we're not going to worry too much about what's causing the fluid motion. We are going to study the motion itself. So just like how the solid mechanics guys, they understand the motion of certain bodies, we're just going to understand the motion of the fluid bodies here. Then the next unit, which is pretty much the core of this particular course is the integral mass, momentum, and energy. So in the third unit, we studied the fluid kinematics. The fourth unit is about the fluid dynamics. So we want to understand when the fluid moves, how it interacts with the nearby surroundings, what kind of forces are associated with it, all that kind of stuff we are going to study in the fourth unit. So to summarize, the second unit is about statics, the third unit is about fluid kinematics, the fourth unit is about fluid dynamics. I've used a word called as integral, which represents one of the approaches to solve the fluid dynamics problems. So we are going to use an integral approach, and I've written that we are going to study mass, momentum, and energy, and that represents the three equations that are used to mathematically represent a fluid motion. That is the conservation of mass, the conservation of momentum, and the conservation of energy. So these three are the physical processes that we need to consider to understand a fluid flow in its entirety. The fifth process or the fifth topic is very important from an application perspective, and it's called as the dimensional analysis. So you might have heard of something being tested in a wind tunnel, for instance. So suppose if you want to design an airplane, so it's not always possible to put that airplane in the testing rig. So what you do is you create a small model of that airplane and you test on that, and based on that testing, you can derive some comparison between the small model and the actual prototype. So in that way, you can compare the results from a small scale version and map it to the actual object, which could be much larger than that smaller model. So that particular study, that is called as the dimensional analysis. So from an application viewpoint or an industrial viewpoint, this becomes very important because not always you have the flexibility or the resources to test these large objects, be it through experiments or through computer simulations. That is why we study the dimensional analysis, so that we understand how these two are correlated, and then we solve only for the small one, and using that correlation, we map the results of the small object to the large object. And the final topic of this course would be an example of a pipe flow. So this is just to reinforce the understanding of the topic number 4. So in topic number 4, we would study, as I said, we would study the equations and the mathematical representation of fluid flow. But what's really the use if you don't really apply it anywhere, right? So that is why in the last topic, we would consider an example of pipe flow, which is of immense practical importance. And then we would use our equations and use that in the pipe flow to see what really happens in the pipe. How does the fluid flows inside the pipe? What sort of forces does it encounter? So all these kind of questions we would be answering in the topic number 6 using the equations of the topic number 4. So in a nutshell, we would be studying a lot about fluids here, but don't get overwhelmed by it. We would be taking it very gradually at the start, and once we have a very fair understanding, then we'll move to the advanced topics as such. So stay connected. Please subscribe to the channel, because otherwise you won't get notifications regarding the latest videos on this channel. We are also having a course on the thermodynamics. So if you're interested in learning thermodynamics, please look at the other playlist that contains the videos on thermodynamics. I sincerely hope that you would learn a lot of new information, and if you have already learned something, you would be able to refresh your concepts but with a better understanding of the subjects. And if some of you are also fond of reading, I'll put some links of the favorite books that I consider according to me for this subject in the description below. So if you want, you can buy some of them. This would greatly enhance your knowledge. I hope that you would learn a lot in this particular subject. And I'll see you in the next lecture where we will be starting with the first topic, which is the terminology and the fluid flow phenomena. Until then, take care and see you very soon. Bye bye.